Hi, this is Mrs. Short. I'm going to go over the review for assessment number 2. I'm going to work out the solutions. So use it to check your work. You can skip ahead, and if you didn't know how to do something, you can use it to see how to do it. All right, this first one, number 1, draw the graph of f of x equals absolute value of x. So a good way to do that, just if you just don't know what to do, is to go ahead and make a little table. So f x and f of x. So if you plug in any number, let's start with like -3. It goes right in here. The absolute value of -3 is +3. So that happens to anything. 0 would be 0, 1 would be 1, 2 would be 2, and so on. So what you end up getting if you graph these points, and you get something shaped like a V. So this is our parent function for the whole chapter here. The absolute value function always looks like a V. It can get skinnier, it can get wider, it can move left, right, up, and down. So we're about to do that in the next problem. So new function is given below. Write all of the transformations that had to be done to f of x to arrive at g of x. So I want to know, how did I go from here to here? So it looks like it was reflected, it was flipped over. So it had a reflection. All right, a reflection over the x-axis. It got moved to the right 5. And what I'm talking about is this point right here, the vertex got moved to the right 5. And then it looks like it has a new slope. So if you count out the slope here, it goes 2, 1, 2, 1, 2, 1. So that one has a positive slope. The other side has a negative slope. But it's really, that all is taken, 2, 1, is taken care of by putting a 2 in front of the whole absolute value bars. So I would say that it has a stretch, because everything is getting taller faster. All right, so the new equation would be this. I put a 2 in front of the absolute value bars. If I want to move something to the right 5, I'd have to put x minus 5 inside. Remember, the inside is kind of opposite of what you think. It didn't get moved up or down, so there's nothing on the outside. But for the reflection, I do have to put a negative sign. All right, so number 2. Given the graph at the right, determine the equation of the function. All right, so this graph right here, the vertex, it got moved from the center over here. So it got moved left 4 and up 2. So left 4 up 2, so put some absolute value bars. Left 4 would be x plus 4. Up 2 would be plus 2. It did not get reflected, and it looks to me like the slope of these lines here are both 1 and -1. So what's the domain? So the domain, remember, is any number that you can plug in. So what can you plug in for x? Well, I can plug anything I want in for x. Okay, so this graph opens up goes to the right, goes to the left, forever. So the domain is all real numbers. So you can put -infinity to infinity, or you can put this double R for all real numbers. Or you could write the words all real numbers. What's the range? So if you look at this graph never goes below 2 right there. So this graph goes 2 up. So it starts at 2, brackets, and comma to infinity. Or you might like to say the y values are greater than or equal to 2. You could say it like this if you like. But I think interval notation is easier. All right, so the domain and range of each of these pictures down below. So number 3. So this right here, we have a parabola. We'll be coming up to that in a couple weeks. So you can see this parabola. It goes down forever. It doesn't go higher than 1, so that would be its range. So the domain, though, is a lot like the absolute value problem we did in the last, number 2. This thing opens up wide forever and ever and ever. So the domain is -infinity to infinity. So the width of this graph is left and right forever. The range, though, is only from, it goes 1 down. So remember, when you're doing the domain and range, you have to mention the smallest thing first. So 1 is the highest this graph gets. -infinity is the lowest. So I would put -infinity to 1, bracket, parentheses. All right, on this line over here, it's a little bit contained. This point right here on the end is -4, -1. And then this graph goes on up to the right. So if I'm thinking about the width, this graph does not go past -4, but it goes off to the right forever. So I would say that -4 is the smallest it gets, and it goes to infinity. I put parentheses on both because this is an open circle. And then for the height, I would say this graph does not go below -1, and then it goes up forever. So -1 to infinity, and again, open. All right, number 4. Number 4, I'm trying to factor. So I need to think, this is a very simple one. Notice there's nothing but a 1 right here. And so it's a very simple problem to factor. I have to think things that multiply to 24, this number on the end. So I need 6 times 4, 12 times 2, 24 times 1, and 8 times 3. Now with these easy problems, I just have to think of which of those things adds or subtract to 10, the center number. So I think I'm going to use 12 and 2. So x and x, and 6 and 4 also make 10, but watch what's going to happen. If I put 12 here and 2 there, this is getting me 2x, this is getting me 12x. 12 minus 2 is 10, so I want my 12 positive, my 2 negative. So plus here, minus there. And also 12 times negative 2 is negative 24. If I had used 6 and 4, the only way to get 6 and 4 to work and make a positive 10 is to have them both positive. And so if I made them both positive, I would never get my negative 24. So what works for one part doesn't work for the other, therefore it does not work. All right, check my factoring. So x plus 12 and x minus 2. So here, x times x is x squared. X times negative 2 is negative 2x. Here, plus 12x. And here, minus 24. So of course, x squared plus 10x minus 24. All right. Number 5. Number 5, factor each completely. So we put these together because they're both perfect squares. Subtraction of perfect squares. You split up your 25 like the square root. We put 5 with an x and 5 with an x because we're basically doing the square root of each part. Square root of 16 is 4 and 4. And 1 plus and 1 minus to get that negative 16. Also, that gets this part, negative 20x, and this part, positive 20x, to cancel out when you're doing this piece right here. Right? They cancel, that's why there's no middle term. Letter B is pretty much the same, but it's just backwards. And if it's backwards, like the x is in the back, you just have to leave it there. You can't switch around subtraction. You cannot make this x squared minus 81. So no, you cannot switch subtraction. It's not the same thing. So I'm just going to split up 9 and 9, put 1 plus x and 1 minus x, and just leave it like that. Looks a little strange, but that's just how it is. Number 6. Number 6, so I notice there's only 2 parts here. I don't notice any perfect squares. I do notice that 12 and 18 both divide by quite a few numbers. They divide by 2, they divide by 3, but the best thing they divide, the biggest thing is 6. So I'm going to pull out a 6. They also both share x to the third. They both have at least x to the third to give me, so I'm going to hit x to the third. So what I'm doing here, in a way, is I'm dividing these parts. So if you want to, you can imagine dividing 6x to the third here, dividing 6x to the third there. Well, 12 divided by 6 makes 2, and there is 1 x left. 18 divided by 6 makes 3, and there's no x's left. So this is your answer here. And 2x minus 3 doesn't factor anymore, so you know you're set. All right, number 7, you're getting to equations here. So with equations, opposite value equations, you want to clean it up. So add 2 to both sides. So I have x plus 5 equals 6. And notice I wrote my opposite value bars. So I now have 2 equations that I'm going to write from this. I'm going to write x plus 5 equals 6 or x plus 5 equals negative 6 because you don't know if it was positive 6 or negative 6 that led to that answer. All right, and this first one, if I take away 5 from both sides, I get x equals 1. And over here, if I take away 5 from both sides, I get negative 11. So I have 2 answers. So if somebody asks you for a solution set, I mean, you can pretty much just write these 2 things, but you can also put these little fancy squiggly brackets and put 1 comma negative 11. You have to put those brackets. You cannot put parentheses. If you put parentheses like this, then that means that's more like a coordinate. So you don't write that. You write this. All right, for letter B, I need to clean this up. I need to divide by 4. So I get 7. So I have 2x minus 3 equals 7. All right, so I make my 2 equations. Either 2x minus 3 equals 7 or 2x minus 3 equals negative 7. Over here on the left, if I add 3, I get 2x equals 10. Divide by 2, so x equals 5. Over here, when I add 3, if I add 3 here, I get 2x equals negative 4. So I get x equals negative 2. All right, so my solution set, everything was working well for me, 5 comma negative 2. Now, over on this next one, letter C, I take away 10 to clean it up. But when I take away 10, something awful happens. I get negative 8. And you all know that whatever is inside here no matter what it is, when I'm done with it, these absolute value bars are going to make it a positive answer. So how could I say that the answer was negative 8? Well, I can't. So remember, if there's a negative sign after you're done cleaning, if there's equal to a negative, you stop and there's no solution. So the solution set for no solution is this. You draw your little brackets, but you leave them empty because there's nothing to say. All right, over here, up top, so now we're getting to inequalities. So these are not that much harder than equations. They're just a little bit more annoying because of the brackets, because the inequality symbols here. So I'm going to add 3 to both sides to clean it up. So I'd have 2x plus 5, absolute value bars, greater than or equal to 7. So this is fine, it's positive. I'll set up my 2 problems. One of them is 2x plus 5, greater than or equal to 7. And then this is a greater than problem. So greater is what we kind of say, so we say the word or. And then 2x plus 5. Remember, you switch your symbol and you make your sign negative. All right, when I take away 5 on the left here, I get 2x is greater than or equal to 2. Divide by 2, I get greater than or equal to 1. Over here, when I take away 5, I get 2x is less than or equal to negative 7 minus 5 is negative 12. And then when I divide by positive 2, I still get less than or equal to negative 6. So another reason these are kind of annoying is because you have to graph your answer. Remember, this is an OR problem, so my graph should go opposite ways. So greater than or equal to 1 goes from here over. Less than or equal to negative 6 goes from negative 6 back. So if you get a graph that doesn't pan out to where it's like going opposite ways, and stop yourself and say, oh my, I did something wrong in my problem. All right, so with letter B, I take away 8. And let me just mention back here, if this had been a less than problem, remember original less than problems, they have connected graphs. So this is like an and graph, and this one, of course, is or down here. All right, so let's see, I'm taking away 8 on letter B. Uh-oh. So I have absolute value of x minus 4 greater than negative 6. I can't do this problem. I have to see what's going on here. So I have a positive. So remember, absolute value always produces positive answers. And so this question is asking me, when is a positive greater than a negative? So always, right? Positives are always greater than negatives. So my answer to this is all real numbers. So no matter what you put in here for x, it's going to work. Because it's going to be a positive, and then you're going to get a bit greater than a negative. So when you graph all real numbers, you have to say those words, and the graph goes just all the way across. Any number will work. Make it true. All right, letter C. Divide this by negative 2. Clean that up. Do not add. This is negative 2 is trying to multiply here, so I divide. So what I end up getting is x plus 3, still inside the bars. This switches to a less than or equal to because I'm dividing by negative, and negative 5. All right, so again, stop. You have a positive thing less than or equal to a negative. So when is a positive less than or equal to a negative? Never. So this graph right here stays blank because there is no answer. And you should say no solution. So your answer is that there is no answer. All right, number 9. The solution to this inequality is these two things. So greater than or equal to negative 7 and less than or equal to 3. So if you solve that to the side, you will get that answer. So I want you to just graph that. So greater than or equal to negative 7. So that goes to the right. Don't go too far because less than or equal to 3. So these things have to be true at the same time. So greater than or equal to negative 7, less than or equal to 3. So they come together because it's an and problem. So the only space of the graph where they're both true is this area here. So remember, negative 7 is a smaller thing, 3 is the bigger. So x, you want the x's between them. And so your symbols always face this way, always open to the right when you write your answer like this. They both have equal bars. You'll notice that this guy right here, he looks kind of exactly like it was. And the other one right here, if you kind of turn them around in your mind, it's really just what you have right there. Okay, so when you're done, then you will know that this looks exactly like letter C is my question. All right, number 10. On number 10, we have to create a graph showing at least 5 specific points. So let me note my transformations here. This thing has been moved to the right 2. It has been moved up 1. So that's the most important thing because that tells me where to start. So right 2 and up 1, right there. Now, there's no reflection, but I do notice right here there's been a shrink. So my graph is going to be wider, the slopes are slower than normal. So from this vertex spot, I'm going to go up 1 over 3, put a new dot, up 1 over 3. Then I'm going to go backwards, up 1, back 3, up 1, back 3. And maybe one more time. All right, so there we go. And should you want to confirm yourself on your calculator, or a lot of the other problems where we wrote equations, you can grab your calculator. Let's see, go to y equals, clear off whatever's there. I need a fraction, so alpha y equals, make a fraction, put in 1/3. Get the absolute value bars. So to get the absolute value bars, you press the math button. You go to the right to number, and there's ABS, number 1. And then put in your x minus 2. So use the x next to the green key, and then subtract 2. Pop out of there and do +1. Press graph, and I see the graph that I made. All right, now let's see. Number 11, describe in words the transformations of this function from the parent function. So we're just writing everything that's changed. So this negative indicates a reflection. This 4 indicates a stretch, so a higher slope. This +5 right here moves you to the left 5, and this 2 there, -2 on the outside, moves you down 2. I just want to mention one more thing. This equation right here might have a less than or greater than symbol to it, and so if that happens to be on your test, I forget. I don't think we're going to put it on there, but I might have left it off this review sheet by accident. If it had a greater than symbol, like if this was f of x is greater than or equal to, remember that you would shade above this. You shade above the graph, and if it had a less than, you would shade below. All right, and remember that if it did not have an equal bar at all, then this solid line that I drew for my graph, the change would be that it would be a dotted line. Okay, all right. Hope this helps. Bye-bye.